Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Farid Daniel. So today I'm gonna present to you about the meaning of sonar and the example of the sonar. So what is sonar? Sonar is short form for sound navigation and ranking. So sonar is a way of communicating, navigating and detecting objects by using a sound propagation. Next, I'm going to present to you about the example of the sonar. Firstly is synthetic aperture sonar, SAS. SAS is an advanced form of sonar technology which is used for imaging and mapping underwater. It is combined the principles of the synthetic aperture radar (SAR) with sonar technology to create high resolution images of the sea floor and underwater objects. So how did SAS work? So there are several types of SAS. First is platform movement. SAS relies on the movement on the sonar platform, which could be a ship, submarine, or autonomous underwater vehicle, to simulate a larger aperture than the physical size of the sonar array. Next, signal transmission and reception. The sonar system transmits sound pulse and then records the echoes that bounce back from the underwater environment. These echoes are received over a period as the platform moving along its path. Next is synthetic aperture creation. By combining the received signals from multiple positions along the platform's path, SAS creates a synthetic aperture. This synthetic aperture is much larger than the physical sonar array, allowing for higher resolution imaging. Next is data processing. So, signal process techniques are used to integrate the received signals over the synthetic aperture. This process corrects for the movement of the platform and compensates for any distortions. Lastly is imaging formation. The process signals are used to construct high resolution images. Next is fish finding sonar. So how does fish finding sonar works? First, sound wave emission. The sonar device emits sound wave pulse into the water using a transducer. This sound wave travel through the water and bounce off objects including fish, seafloor, and underwater structure. Second is echo reception. The transducer then listens for the echoes of this sound wave as they return. Different objects return echoes at different times, intensity depending on their distance and size. That is signal processing. The fish finder process these return echoes to determine the location, size, and composition of the objects. Modern fish finders use sophisticated algorithms to distinguish between fish and other underwater objects. Lastly is visual display. The process data is displayed on a screen, usually in the form of graphical representation. Fish are often shown as arcs or dots, while the bottom contour and structure are depicted as lines or shapes. Next, we go to echo sounder. So, how the echo works? First is transmission of sound pulses. The echo sounder transmits sound pulse pings downward into the water from a transducer mounted on the hull of the boat or ship. Reflection of the second is reflection of sound wave. This sound wave through the water and reflect back upon hitting the seafloor, underwater objects, or the water column. That is reception of the echoes. The transducer receives the reflected sound wave, so the time it takes for the echoes to return is recorded. Lastly is depth calculation, deep calculation. The echo sounder calculates the water depth by measuring the time travel between the transmission of the sound pulse and the reception of the echo.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Taufik Hidayat bin Mansur. So, I'm about to present the sonar operating principle and also the types of sonar. So, let me start with operating principles of sonar. One of the operating principles is sound speed. So, from the sound speed, when we combine the sound speed in water with the time taken for the reflection to be received, the sonar systems calculates the distance the sound has traveled. So, there is formula for this operating principle. which is shown in the slide. So from the formula, we can understand that the variations in sound speed can significantly impact the accuracy of distance measurements. Typically, the speed of sound in salt water is around 1500 milliliter per second, but this can vary with changes in depth, temperature, and also salinity. Sound speed calculators can provide better approximations in varying environments, although scanning sonar systems cannot precisely calculate sound speed. They can adjust displayed values to match the operating conditions. Now, let's go to the next operating principles of sonar, which is target reflectivity. So we can understand that the sonar targets with materials like rocks, metals, and gas. They produce strong reflective echoes due to their high density compared to water. In contrast, materials like sand, mud, silt, and plants produce weaker echoes because their densities are similar to water, and also they absorb sound energy. So, on a sonar device, strong echoes appear as bright indicators with vivid colors. In typical palettes, bright colors indicate strong echoes, while dark colors indicate weak echoes. So next operating principles of sonar is sound beam patterns. So we can understand that scanning sonar is like using a flashlight in a dark room. Only the area illuminated by the light is visible, while the rest remains dark. Unlike light beams, sonar's acoustic beams have a fixed height and width known as the beam pattern. These acoustic beams illuminate the target area with sound energy instead of light. Scanning sonar systems typically have a narrow horizontal wide vertical beam, which transmits energy in a narrow path from the transducer. The transducer's head rotates with a stepper motor, moving in an arc to create a slices of the object's image on the display. Using the flashlight analogy, if you take pictures as the light sweeps across the room, you'll capture slices of the lit area. By combining these slices, you can see the entire illuminated area. So let me continue on the types of sonar, which is one of it is active sonar. So basically, active sonar, it emits sound wave and captures the echoes to determine a target's range, direction, and movement. Basically, object like submarines utilize active sonar to send out sound wave and detect objects by measuring the time delay of the returning echo. So modern technology can now provide detailed information about the size, orientation, and shapes of objects. So things like deep tracker ROVs, they use active sonar to emitting the sound waves and measuring the time they take to return after bouncing off objects and the seafloor. Uh, Multi-beam imaging sonar employs multiple sound beams to create a detailed image of the area in front of the ROV. Next types of sonar is passive sonar, which is in surveillance scenarios. Passive sonar system can be used. So these systems don't need a local transmitter. They listen to sound wave from other sources. Unlike active sonar, which emits sound pulses and listens for echoes, passive sonar only listens for sound from sea life, ships, and other sources. However, passive sonar cannot determine the location of the sound source on its own. It requires multiple listening devices working together to pinpoint the transmitter's location without revealing their presence, which is crucial in military settings.
Assalamualaikum warahmatullahi wabarakatuh and hi everyone. I am Hazrul Daniel Hafifi bin Azrul Hisham, gonna present to you about category and application of sonar devices. Devices can be classified into different categories based on their application and its capability. The first one is navigating with echo sounder sonar. Echo sounder sonar are instrumental in conducting bathymetric studies. They are widely used in various maritime applications, including navigation for ship, charting for safe passage, underwater mapping for scientific and research, and assessing potential hazard. Number 2, single beam echo sounder sonar. Single beam echo sounder sonar, or known as SBES, emit a single sound beam vertically downward from the water surface toward the seafloor. This type of sonar are used on most commercial marine vessels and are the same technology used in fish finder. Because of single beam echo sounder are relatively simple, they are most cost effective and easy to operate option for bathymetric survey and are particularly useful for small scale hydroponic survey. 3. Multi beams echo sounder sonar. Like single beam, multi beam echo sounder sonar, or known as MBES, measure water depth but with much detail and utilizing multiple beams to cover a wider area, allowing for more detailed and efficient mapping of seafloor. This high-resolution bathymetric data show details that are instrumental for accurate hydrographic surveying, underwater mapping, oceanography, research and exploration, and navigation for all types of marine vessels. Number 4. Side scan imaging sonar. Side scan imaging sonar is specifically designed to produce a detailed image of seafloor along a transient line that can be mounted on hull of a ship or ROV for submerged object detections. It emits sound wave perpendicular to the direction of travel and capture the reflection of seafloor. This type of sonar provide information about the shape, texture of seafloor by creating the black and white or grayscale image, where the lighter shade represent hard reflection surface and a darker shade indicates softer and less reflective area. Application of sonar in marine navigation. In marine navigation, sonar is crucial for safe travel. It measures water depth using echo sounder, helping ship avoid underwater obstacles. This technology prevents accidents by identifying hazards like submerged rock and other vessels. Number 2. Application of sonar in fishing. Sonar technology has greatly improved fishing by making it easier to find fish and understand underwater structure. Fishermen use devices called echo sounder that send sound wave into water. Overall, sonar makes fishing more efficient and productive. Number 3. Application of sonar in military. Sonar is vital in military operation, especially for naval force. This is crucial for anti-submarine warfare, allowing military forces to find and engage enemy submarines. I think that's all from us. Thank you.